Let us discuss now inverse cosine function. So let's start with y equals cosine x. And based on the previous discussion, the domain of this function is the set of all real numbers while its range is from -1 to +1. The same process with what we had a while ago for sine function. We also need to restrict the domain of this function from 0 to +pi so that cosine function is a one-to-one function and we can find its inverse. With that, again, the domain will be from 0 to +pi, the restricted domain, while its range is still the same from -1 to +1. For the inverse cosine function, we're not going to show anymore the proof on how to find the inverse of this cosine function because this is the same with sine function. So we'll have y equals inverse cosine x or y equals arc cosine x. At this point, we now have this curve which will illustrate the graph of inverse cosine function. A while ago, for y equals cosine x, the range is from -1 to +1, and that will now be the domain of our inverse cosine function. That is from -1 to +1. That is the allowed values for cosine only. While the range will be the angles that produce the cosine function, which are from 0 to +pi. Now we proceed with the examples about inverse cosine function. Let us try to find the inverse of negative square root of 2 over 2. If we let this expression be equal to theta, finding the inverse, okay, meaning going back to cosine function, we'll have cosine theta equals negative square root of 2 over 2. So if we look at this unit circle, if we are to determine the angle that will give you negative square root of 2 over 2, we'll have 3 pi over 4. Okay, we'll have this cosine value, the angle correspond to this is 3 pi over 4. So at this point, we're going to have only the lowest possible value, which is from negative or which is 3 pi over 4. We're not going to deal with some other possible angles because we are only going to follow the domain and range of the restricted inverse cosine function and restricted cosine function. Thus, cosine of 3 pi over 4 is negative square root of 2 over 2. Again, since inverse cosine of negative square root of 2 over 2 is our theta, thus theta is 3 pi over 4. Okay? Again, we find on the unit circle the angle that will generate cosine of negative square root of 2 over 2, which will give us 3 pi over 4. You can also use in your calculator to verify this one. So kindly input the or press shift cosine and negative square root of 2 over 2. And the result will be 3 pi over 4. Let us proceed with our next example. So find the exact value of inverse cosine of cosine pi over 3. So again, the first process or first step will be finding the value correspond to cosine pi over 3. So for cosine pi over 3, you have the ordinary cosine. So pi over 3 is 60 degrees. That will be equal to 1/2. Okay, so cosine pi over 3 will be equal to 1/2. And then for the cosine inverse or inverse cosine of cosine pi over 3, we'll get the inverse cosine of 1/2. And if you're going to check, okay, what will be the angle that will generate cosine, which is equal to 1/2, and that is pi over 3. Thus, the exact value for inverse cosine of cosine pi over 3 is equal to pi over 3. For us to easily answer this kind of situation, especially for composition of the ordinary sine and the or cosine, and then the inverse of the given cosine function, we need to recall the composition of functions. That is, for all x in the domain of the function f and its inverse, inverse functions have the following properties. First is the composition of f and f inverse of x is equal to x itself, okay? And f inverse of f of x is equal to x. That means for this given example, inverse cosine of cosine pi over 3, we can simply say that this will be equal to pi over 3. We can simply cancel out the operator cosine inverse and cosine. However, this is only applicable for their domain and range. So let's say for the function or for the sine function, cosine and tangent function, will have for sine, arc sine of x that is equal to arc sine of sine y equals y. Again, that is only possible if this domain and range are applied for both or for all of these inverse trigonometric functions. Now, to understand a tangent function, let us consider first the graph of this function. Okay, we have y equals tangent x. And considering the horizontal line test, this will not pass, or the given tangent function will not pass the horizontal line test. And this is not the one-to-one. It doesn't have an inverse. So with that, we need to again restrict the domain of the function from negative pi, okay, pi over 2 to positive pi over 2, while the range will be the set of all real numbers, so that this tangent function will have an inverse. And if you take the inverse of this tangent function, we'll get now this graph whose domain is the set of all real numbers. Okay, we interchange the domain and range from the previous tangent function for us to find the domain and range of this inverse tangent function, while the range will be from negative pi over 2 to positive pi over 2. Negative pi over 2 and positive pi over 2 are not included in the range. We'll have y equals inverse tangent. We have tangent raised to negative 1 of x. Let us proceed with the example about inverse tangent function. Let us find the exact value of inverse tangent square root of 3. Okay, so looking at the circular functions, because a while ago for sine and cotangent, this was our basis in finding their exact value. So same here, if we use the circular function, okay, to find the exact value of inverse tangent square root of 3, we have here the corresponding points, which will be about sine and cosine. Now, for inverse tangent, we first let the given expression equal to y. Okay, so inverse tangent of square root of 3 will be equal to y. Now, if we take tangent of both sides of this equation, we'll have tangent of y will be equal to the tangent of the inverse tangent square root of 3, which will be equal to tangent of y and then square root of 3, since we can cancel out the tangent and the inverse tangent operating on square root of 3. If you're going to recall, for tangent y equals square root of 3, okay, for tangent function, this is equal to, as an identity, we'll have sine y over cosine y, which equals square root of 3. Therefore, we need to find an angle y, okay, that when we substitute for sine and cosine and simplify them, that will give you square root of 3. So looking back at this unit circle, if we use pi over 6 or 30 degrees, we'll have 1/2 divided by square root of 3 over 2, which will give us square root of 3 over 3. Okay? For pi over 4, square root of 2 over 2 divided by square root of 2 over 2, this will be equal to 1. Okay? So our goal is to look for square root of 3 only. For pi over 3, if we divide square root of 3 over 2 and 1/2, this will surely give us square root of 3. That means for the y value, we'll have sine of pi over 3 divided by cosine of pi over 3, which will be equal to square root of 3 over 2 divided by, okay, what was again our cosine for this one? Let's go back to the unit circle. We have square root of 3 over 2 divided by 1. Okay, and if you divide this one, we'll have, let's use our calculator to verify this. Square root of 3 over 2 divided by 1/2, indeed will get square root of 3. So this will now be, oops, let's go back to this, square root of 3. Therefore, the value of y will be pi over. Inverse tangent of square root of 3 is equal to pi over 3. Although, at this point, medyo tricky siya kasi we apply trial and error, the process of trial and error to find the inverse tangent. Okay? But you can verify your answer using your calculator, whether you got the same or correct answer. So that's it for the inverse tangent function. Now we proceed with the remaining inverse trigonometric function. So let's start with the cotangent function. So this is the graph of the restricted cotangent function. And if we get the inverse of cotangent function, we'll have this illustration. Yun yung inverse niyan, and if as it reflect on the line y equals x, we'll have this graph. So the domain of this is the set of all the real numbers, continuous siya for both left and right side of this x-axis, and its range should be from 0 to positive pi. Okay? 0 and pi are not part of the interval. We also have for second function, which will be represented by this graph. Okay, this is for second. For inverse second function, we have this illustration. Whose domain will be the absolute value of greater than or equal to 1, while the range is on the interval 0 to pi over 2, union pi over 3 pi over 2. Because at this point, the second function is undefined from negative pi, or from, sorry, pi over 2 to positive pi. Okay, so at this part, second is undefined. For cosecant function, we have this illustration for y equals secant, or cosecant rather. In terms of the graph of the inverse cosecant, we have this illustration. And looking at this illustration, we'll have the domain as from negative infinity to negative 1, union 1 to positive infinity. That means the second function is undefined on the interval negative 1 to positive 1. Okay? Well, the range should be from negative pi to negative pi over 2 union 0 to pi over 2. Okay? So now let's proceed with the rest of the examples about this lesson. So let us try to find the exact value of this expression. We have the tangent of the quantity, tangent inverse of negative 1/2 plus tangent inverse of pi over 3. For this example, okay, for this expression, let's write our solution here. Okay, if you're going to recall, okay, our previous lesson, which is about, okay, proving identities, proving trigonometric identities, the form of this expression is the sum of two angle identities, right? If you still recall the sum of two angle identities, which is now of the form is 1. Okay? Your alpha is this inverse tangent of negative 1/2, while your beta is inverse tangent of 5/3. That means, if we get the exact value of this expression, we have tangent of the inverse tangent of negative 1/2 plus the inverse tangent of 5/3, applying the sum of two angles identity, we will have now the tangent of, again, that is tangent inverse of negative 1/2. Again, allow me to write it here so that you have a guide. For the sum of two angle identities for alpha and beta, that is equal to tangent alpha. Sorry, this is alpha. Let me erase this one. Tangent alpha plus tangent beta. Okay, all over 1 minus the product of tangent alpha, tangent beta. With that, okay, following this form, our alpha is again inverse tangent of negative 1/2 and our beta is inverse tangent of 5/3. That will be tangent of inverse tangent negative 1/2 plus tangent of your beta, which is inverse tangent of 5/3. Okay, so with that, we'll have now, or by the way, our denominator, that is 1 minus tangent of, okay, product of tangent alpha and tangent beta. So we'll have tangent inverse of negative 1/2 times tangent inverse 5/3. Okay, now let's simplify this one. We can technically apply composition of functions for this one, especially that the included values are part of the domain of the function. Okay, negative 1/2 and 5/3 are part of the domain of inverse tangent function, especially that the domain of the inverse tangent function is the set of all real numbers. So this will be cancelled out because we can remove or cancel out the tangent operator by following the property for inverse functions. Negative 1/2 plus 5/3 divided by 1 minus the product of negative 1/2 and 5/3. 7/6. Our denominator will be 1 plus, this is now negative 1 times 5, so 5/6. And simplifying this, if we use our calculator, we'll have 7/11. Okay, that means tangent of inverse tangent negative 1/2 plus inverse tangent of 5/3 is simply equal to 7/11. Let us proceed to our next example. So in this case, we are asked to find the exact value of sine of cosine inverse 4/5. Okay, so what if we have this kind of situation wherein it is not 1/2 nor 1 nor pi/3 square root of 3 and the rest of the values included, or what we know that are included in the unit circle. So this is somehow unnatural because we are used to have an angle that are in radian or in degrees. But what if we have 4/5? Okay, so at this point, we are going to begin at the end side. Okay, so we will start at inverse cosine 4/5. And if we use or represent this angle as theta, we'll have inverse cosine of 4/5, meaning this will be sine theta, right? So, but first we need to find cosine inverse of 4/5, which means cosine theta is equal to 4/5. Take note that theta is the same with y. Both of them are just variables or symbols. Next is We also have to find sine theta. So this means we are looking for sine theta. But anyway, we can use the Pythagorean theorem in finding the exact value of this expression. That is for sine squared theta. Okay, note that sine squared theta plus cosine squared theta is equal to 1. Okay? Or we can say y squared plus x squared is equal to 1. So if cosine theta is 4 over 5, therefore, if we substitute for fifth in this equation, we'll have sine squared theta equals 4 or plus rather. So this is plus 4 over 5 squared equals 1. And if we solve for sine squared theta, we'll have sine squared theta equals 1 minus, so 4 squared will be 16 over 5 squared is 21. Thus, we'll have sine squared theta equals now 9 over 25. And finding sine only, not sine squared, we have to get the square root of both sides of this equation. So it means that sine theta is equal to plus or minus the square root of 9 over 25, which is 3/5. Okay? Now, for us to check whether the correct value is positive or negative, since theta, okay, which is cosine inverse of 4/5 is in quadrant to 1, okay, again, we are referring to the right triangle rather form on the quadrant 1, then sine theta must be positive. Thus, okay, thus sine theta is equal to 3/5, which is equal to this expression. So, therefore, let's write it here. Okay. Sine of cosine inverse of 4/5, okay, is equal to 3/5. This is the exact value of the given expression. Let's proceed with the next example, which is about arcsecant 2. Okay, so for us to answer this one, okay, this example, we need to simply find the identity for secant, okay, for arcsecant. But in this case, we're looking at the value so that we find the angle. Recall that secant theta is equal to 1 over cosine theta. That means for arc secant 2, this means arc cosine of 1/2. Okay? This is the value. This is the output. As we are need the angle, so we can find the reciprocal of this one. Not when we say that arc secant is 1 over arc cosine, but we need to find the reciprocal of the given value, assigned value, not the entire inverse function. And if you're going to look at the unit circle, for arc cosine 1/2, if you would like to find the angle that will generate cosine of 1/2, we'll have pi over 3. That means arc of secant 2, that is equal to pi over 3. Again, hindi yung arc cosine ang kunin natin ang reciprocal value, kundi yung input. That will be from arc secant 2, this is equivalent to arc cosine of 1/2. Again, for arc secant theta, this means arc cosine of 1 over theta. Theta, yung kunin natin ang reciprocal value, not the cosine itself. Let's proceed with the next example. For cosecant inverse of -2, recall that reciprocal of cosecant is sine. So that means for this example, for us to find the exact value of inverse cosine -2, This means inverse sine of negative 1/2, reciprocal of negative 2. Okay? And again, looking at the unit circle for inverse sine of negative 1/2, okay, yung angle that will generate sine which is equal to negative 1/2 is equal to negative pi over 2. That means cosecant inverse or inverse cosecant of negative 2 is negative 1/2. Now, let's proceed with the next example. So, in this case, what is the exact value of cotangent of r cosecant of negative 3? Take note that for this example, we cannot use the composite function or the composition of function because what we have here are cotangent and cosecant, and they are not reciprocal identity. With that, we first begin at the inner part of this expression. So let's write solution at this point. We say theta be equal to arc cosecant of negative 3. That means cosecant theta is equal to negative 3. Again, if you take the cosecant of both sides of this equation, we'll have cosecant theta equals cosecant of arc cosecant. So we can cancel out the operating cosecant and we'll get negative 3. We can use Pythagorean theorem. That is, for this one, I'm not sure if we were able to encounter this one when we talk about trigonometric identities. Okay, that another form of Pythagorean theorem is that 1 plus cotangent squared theta is equal to cosecant squared theta. If you have cosecant squared theta, and at this point, cosecant theta is negative 3, we can substitute this value into this equation. So we'll have 1 plus cotangent squared theta equals negative 3 squared. Okay, which will be equal to 1. That means cotangent squared theta is equal to 9 minus 1 or 8. Therefore, if we take the square root of both sides of this equation, we'll have, now hindi siya kasya, lagay na lang natin dito, cotangent theta equals plus minus the square root of 8. So again, our concern is whether we have positive or negative value for 8. Or this is equal to positive or negative 2 square root of 2, right? What we have here is cosecant, and it is on the interval, our cosecant and of negative 3, this is on the interval negative pi over 2, 0. Okay? Which is negative. That means what we are going to do here or use here is the negative value of cotangent. Therefore, let's write our conclusion here. Cotangent theta is equal to negative of 2 square root of 2. Since theta is equal to r cosecant of negative 3, hence cotangent of r cosecant of negative 3 is equal to negative 2 square root of 2. And this will be the value that we are looking for. One important thing here is you must know the domain and range of each inverse trigonometric functions. Let us proceed with the applications of inverse trigonometric functions, which are about angles of elevations and depressions. Okay, although this topic has a lot of applications, but we're only going to focus with elevation and depression. Let's proceed with angle of elevation. This topic or this angle of elevation is the angle between a horizontal line from the observer and the line of sight to an object that is above the horizontal line. This angle of elevation is also known as the worm's eye view. Somehow you are on the ground and looking at a higher, let's say, object or an object that is in a higher location. Okay? While the angle of depression, bird's eye view, okay, it is the angle between a horizontal line from the observer and then the line of sight on the object that is below the horizontal line. So let's proceed with this example. You have a 120 feet building cast a 45 feet shadow. What is the angle that the sun hits the building? So if you're going to illustrate this problem, you have, or situation, you have a building that is 120 feet in terms of height. So we'll have 120 feet. This is from this point to here. Okay? So it casts a shadow that is 45 feet. So if this is 150 feet, it casts a shadow somehow up to here. Let's say this is 45 feet. What is the angle that the sun hits the building? And for us to find the answer to this question, let us form right angle at this illustration. So let's say you have this angle and we connect this endpoint to this point. We'll have this right angle. You have this right triangle, right angle, and then we have this angle here and here. Okay, but since what we have here are 120 feet, let's say the height of the building and the length of the shadow of the building, we have 45 feet, which is, if you're going to imagine this and put this in a Cartesian plane, the height of the building will serve as the y value and the shadow will be the x value. Okay? And we need to find the angle here. We can use the tangent function if you let this angle be theta, and this is the angle that we're looking for. So if that angle is theta, therefore we'll have tangent theta be equal to, so we have the opposite over the adjacent, that is 120 over 45 feet. Okay, they are in feet. And solving for theta, okay, we get the inverse tangent of both sides of this equation. This is inverse tangent of 120 feet divided by 45 feet. So we can cancel out the tangent operating on theta. And on the right side, we can solve for the inverse tangent of 120 over 45 feet. Might as well use our calculator for this. Okay, so that is in radian measure. We'll have 1.2 radians if your calculator is in radian. So kindly check on the unit of the angle, and if it is in degree, that is approximately 69.4 degrees. So meaning this angle is equal to 69.4 degrees or 1.2 radians. For this last example, an aerial photographer who photographs a real estate properties has determined that the best photo is taken at a height of approximately 453 feet and a distance of 873 feet from the building. What is the angle of depression to the building? If we identify the given for this situation, it says that the height is approximately 453 feet. This is above the ground, 453 feet. And then the distance from the building, and let's say your camera is 873 feet. So if this is your building located here, you have this illustration. Okay, the camera is over here, which is its height is 453 feet. The distance from your building and this camera is 873 feet. Since we need to find the angle of depression, this angle right here, this will serve as your theta. Okay, what trigonometric function is applicable in this case? So what we have here is the adjacent side, and then the hypotenuse. That means we can use cosine. Okay, that is cosine theta is equal to adjacent over the hypotenuse. Since the adjacent side will serve as the height, okay, of that camera above the ground, which will be equal to 453 feet, we'll have 453, and then the distance between the camera, and the building is 873. So this is 873. Both are in feet. We have cosine theta. And if we take the inverse cosine of both sides of the equation, we'll get theta equals, so inverse cosine of 453 divided by 873. Let's check using our calculator. So inverse cosine of 453 divided by 873 will have 58.74 degrees. Okay, so this will be the angle of depression to that building. Okay, so I hope that this example is clear to you, my dear students. That would be our discussion on inverse trigonometric functions. So if you have any questions or clarifications, you can ask your teacher for further illustration about the topic. Okay, so thank you so much for watching and see you next time.